Welcome to my Advanced Database Management System course. In this section, we discuss about performance tuning, identify performance bottlenecks, set performance goals, optimize database design, indexing strategies. Let's enjoy. Performance tuning is the process of optimizing the performance of a database system to improve responsiveness, throughput, and efficiency. Here are some best practices for performance tuning in database management. 1. Identify performance bottlenecks. Conduct performance monitoring and analysis to identify bottlenecks and performance issues in the database system. Use performance monitoring tools, database logs, and system metrics to pinpoint areas of concern. 2. Set performance goals. Define clear performance goals and objectives based on business requirements, user expectations, and service level agreements, SLAs. Establish benchmarks and performance metrics to measure progress and success in achieving performance targets. 3. Optimize database design. Design and optimize database schema, tables, indexes, and queries to minimize resource consumption and improve query performance. Normalize database schema to reduce data redundancy and improve data integrity. Use appropriate data types, constraints, and indexing strategies to optimize query execution. 4. Tune SQL queries. Identify and optimize poorly performing SQL queries that contribute to performance bottlenecks. Use query optimization techniques such as query rewriting, index optimization, query hints, and query plan analysis to improve query execution times and resource utilization. 5. Indexing strategies. Use indexes strategically to improve query performance by speeding up data retrieval operations. Identify frequently accessed columns and use indexes to support selective queries and search conditions. Consider the trade-offs between query performance and index maintenance overhead. 6. Database configuration. Configure database parameters, memory allocation, buffer pool size, and cache settings to optimize resource utilization and improve overall system performance. Adjust configuration settings based on workload characteristics, system resources, and performance requirements. 7. Hardware optimization. Optimize hardware resources such as CPU, memory, disk I/O, and network bandwidth to support database operations efficiently. Upgrade hardware components or scale out horizontally to accommodate increasing workloads and demand. 8. Query caching and result set optimization. Implement query caching mechanisms to cache frequently executed queries and result sets in memory, reducing query execution times and database load. Use stored procedures or materialized views to pre-compute and cache complex query results for faster access. 9. Partitioning and sharding. Consider partitioning and sharding strategies to distribute data across multiple physical or logical partitions, improving scalability and parallelism. Partition large tables based on access patterns, data ranges, or key values to distribute workload and optimize query performance. Monitor and tune regularly. Continuously monitor database performance metrics, system resources, and workload patterns to identify performance degradation and emerging bottlenecks. Implement proactive performance tuning strategies and conduct regular performance reviews and optimizations. Load testing and capacity planning. Perform load testing and capacity planning exercises to simulate production workloads, identify scalability limits, and ensure that the database system can handle peak demand and growth projections. Scale resources and infrastructure accordingly to accommodate increased workload and user concurrency. 12. Document and documentation. Document performance tuning efforts, optimizations, and best practices for future reference and knowledge sharing. Maintain up-to-date documentation of database configurations, tuning parameters, and performance monitoring procedures. By following these best practices for performance tuning, database administrators can optimize the performance of their database systems, improve user experience, and ensure that the database infrastructure meets the performance requirements and expectations of the organization. Regular monitoring, analysis, and optimization are essential for maintaining optimal performance and responsiveness in dynamic and evolving database environments. Thanks for watching the Advanced Database Management System lesson. Hope you enjoy the lesson. To learn more about Database Management System, please check the next lesson. Never stop learning. Thanks once again to enjoy the lesson.